And welcome back, and we're on to the 30th of Jan, higher plus 5 a day, and we're almost near the end of the month. First question. Okay, so we have a make y the subject of the formula. This one's not too bad because y only appears once, so there's just some rearranging. There's no collecting or factorising necessary here. So let's just do this step by step. So I'm going to start by using my reverse trick, whereby I'm going to say if w minus something equals something, then I can switch the w and the something around. Makes slightly more sense if I write it down. And that comes from the idea, let's take some numbers like 12 minus 4 is 8 and 12 minus 8 is 4. I can switch the two numbers around. A bit easier than doing this sort of couple of steps. Then I'm going to divide by 4a, and so that's going to tell me that w minus c over 4a is equal to y cubed. Take the cube root of everything, and that means that y is going to be equal to the cube root of w minus c over 4a. And that is the first question done. Next question. Okay, so what's a perimeter of the sector? So a bit of a classic sort of both GCSE and further maths question actually, but really just involves setting up, being careful and not missing out the obvious point. So you don't have to write this bit out, but just to note, so the perimeter is O to A plus the arc A to B, and then plus the radius B to O. And it's those radii that people tend to forget. So making this an equation, 22.81 is equal to 5.3 plus, I'm going to write the radius next because it's slightly easier, plus 5.3 plus the angle. So in other words, it's the fraction of the circle. And the circle has a total length or circumference of 2 pi r, which is 2 pi times 5.3. Which means I have one equation, it's a bit messy, and one unknown, and then I just need to solve it. So if we take away 10.6 on both sides, and then we divide by, or actually multiply by 360 over 2 pi times 5.3, that's what I'm doing. But let's write that out, because that's not the easiest thing. I'm going to do 22.81 minus 5.3 plus 5.3, which is 10.6. So let's do that as 1. And then I'm going to multiply that by the 360 and divide all of that by the 2 pi times 5.3. And let's put brackets around this just so bid maths works slightly better. If I put that in my calculator, which I'm going to do now, I then get that theta is equal to, well, my calculator says 131.999 degrees. So I'm guessing the numbers were made to make 132 degrees. But let's say that's the 3 sig fig, and my accuracy is correct. Next question. All right, what do I have? So I've got a Venn diagram. Okay, now this is an interesting one. So a Venn diagram with two circles within it only has 4 bits. The bit that's just in C, the bit that's just in D, the bit that's in the middle, and the bit that's in neither. And in this case, I know all 3 bits. So it must be the case that x times x plus 3 plus 7 plus 4x plus 3x minus 6 must be equal to the total, which is 40 students. And as you hear me say every now and again, one equation, one unknown, I just need to solve this. Now, because I can see I've got x squared, it's going to be a quadratic, so I can kind of see what's going to happen. Let's go through it anyway. So x squared, be careful here, because this is where the marks are lost and they carry through. So x squared plus 3x plus 7 plus 4x plus 3x minus 6 minus 40 is equal to 0. And then let's add these up carefully. Now, you may have seen me do this before. We're going to tick as I go. So there's my x squareds. My x's are 3 plus 4, which is 7, plus another 3, which is 10. So plus 10x. And my numbers are 7 minus 6, which is 1, minus 40, which is minus 39, is equal to 0. And does that factorize? Yes, it does. Into x plus 13, x minus 3. And that all equals 0, which means that x is either equal to 3 or x is equal to minus 13. Now, because the Venn diagram, especially because this one here, has positive x's only, it must be the case that x is greater than 0. So I'm going to write here to show the examiner x is greater than 0, which means I'm going to exclude that one and include this one, which means that x is equal to 3. And then on the diagram, I'm just going to replace all the x's and stuff with 3. So if we look at this one here, 3 times 3 plus 3 is 18, 7 is 7, 4 times 3 is 12, and 3 times 3 is 9, minus 6 is 3. If I just check this quickly, so 18 plus 7 is 25, plus 12 is 37, plus 3 is 40. That has indeed worked. Now, what's the question you want me to do? I'm going to all this, haven't got to the question yet. A student is shown at random, they own a dog. Okay, so there are 19 people that own a dog. Work out the probability that they own a cat, given they own a dog, I guess is what they're trying to say. So there's 19 people that own a dog. 7 of those also own a cat. So therefore, the answer to this one is going to be 7 over 19. Conditional probability question, but a nice one. Next and final question today. What do we have? A group of 10 people enter a room. Each person shakes hands with the other one. Okay. It's called a shaking hand problem, I think. It's got some really obvious names. It's quite a nice little question. It's all to do with combinations. Let's think about the first person. So the first person is going to come in and they can shake hands with any one of 9 different people. The next person is going to come in and they can also shake hands with 9 different people, but we can't count the same one twice, so they only have 8 people left. And then 7, and then 6, and then 5, 4, 3, 2, and 1. So the question really is, what is the total amount of those handshakes? So I need to add all these numbers up. Now, you might know a quick method of doing this already. There is definitely one, but let's do the pairing method. So if I write my numbers out, so I want 1 plus 2 plus 3 plus all the way up to 9. And if I write them back to front, that's 9 plus 8 plus 7 plus 1. And each of these pairs add up to 10. And I have 9 of these pairs because there's 9 numbers. So therefore the total is 90. But the things I've doubled it, haven't I? Because I've got one list there and one list there. So I'm going to have to halve this, which gives me 45 handshakes. Nice question to end. I'm going to say the usual comment I say every day because it is relevant again. So nice little mix of questions going on here. Bit of algebra, a bit of rearranging, bit of Venn diagrams, and a bit of combinations at the end. As ever, like, subscribe, any comments down below. We'll get back to you, and I'll see you for the next one. Thanks all.